Namaskar. I am working in Kutch Chemical, Gujarat. Now we will discuss about saturator. Why this word is saturator? You see it. Saturator means when ionic product of a salt is equal to Ksp value of that salt. You see, ionic product of the salt is equal to Ksp value of the NaCl, that is called saturated. From this saturated word, it came as a saturator because here the ionic product of NaCl is equal to Ksp value of the NaCl. That means 100% of the NaCl is dissolved in hot brine. Next, that's why its name is saturator. Then you come to ionic product. If ionic product is greater than the Ksp value, it is called precipitation. The ionic product of a particular salt, if it is greater than the Ksp value of that salt, then there is a precipitation. Third is when ionic product of the salt is less than Ksp value of that salt, that is unsaturated. For example, when oil in water, when oil is floating in water, that is called unsaturated, or ionic product of that particular salt is less than the Ksp of that salt. Okay. When salt is being fed to saturated under the hot brine which is coming from cell, it is dissolved, it gives as a Na plus Cl minus. It is fully saturated. Here the solubility of the NaCl is equal to the ionic product of the equal to the Ksp value. And then here we will discuss the calcium sulfate. Calcium sulfate, we should know that the sulfate is present in salt as a calcium sulfate, but not as a sodium sulfate. That calcium sulfate, when hot brine is charged into the saturator, the calcium sulfate of the salt, it is 25% there is a precipitation. So the Ksp value of the calcium sulfate goes down when temperature increases. So there is a precipitation of calcium sulfate in saturator. It is called clogging deposit. Clogging deposit. What is this? When the calcium sulfate that is make a coating on a particular NaCl crystal, it is very hard, and whatever the hot brine it may be, but this due to clogging deposit, the crystal remains very strong. It cannot be dissolved in the hot brine. It is a clogging deposit. Due to clogging deposit, there is a loss of salt in saturator. If you will recover the salt from the clogging deposit due to calcium sulfate, if you will charge barium chloride or barium carbonate into the saturator, it may be that calcium sulfate may be removed, and the whole NaCl crystal can be dissolved. It was examined in Kanjam plant. Okay, stop. From saturator, the hot brine comes to PPT tank. In PPT tank, we are adding reagents, chemical reagents as NOH. NOH added MgCl2 plus 2NaOH. It gives 2 NaCl plus MgOH2. This gives, and how it gives. So say our magnesium chloride plus 2NaOH is NaCl and magnesium hydroxide. The Ksp value of the magnesium hydroxide we will find out. We will find out the magnesium hydroxide Ksp value of magnesium hydroxide. Magnesium hydroxide, it is 1.9 into 10 to power minus 11. So as per ICE table, I is initial, it is change, it is equilibrium. Stop it. We will discuss PPT. PPT means it is precipitation. We will discuss here magnesium hydroxide. It is Ksp value of magnesium hydroxide is equal to 1.9 into 10 to power minus 11. So we will discuss it is magnesium hydroxide. Ksp equal to magnesium plus into 2OH minus. If it is X, it is 2X squared. So Ksp is equal to 2, it is 4X. It is 4x cube. 4x cube equal to 1.9 into 10 to power minus 11. Then x is equal to 1.9 into 10 to power minus 11 by 4, 1 by 3 is equal to 1.68 10 to power minus 4. Okay, good. Therefore, solubility of magnesium hydroxide equal to 1.68 into 10 to power minus 4 into molecular weight of the magnesium hydroxide, that is 58. It is the molecular weight of the magnesium hydroxide. Then we will get 1.68 into 58. So it is 97.44 10 to power minus 4. It is greater than the Ksp value of the magnesium hydroxide. That's why it precipitates in clarifier, in precipitation tank and moving towards clarifier. Then due to solubility is a chemical properties of the chemical properties. What is solvation? Solvation is the molecule of the solvent that associate and making attraction to the molecules of the solute. That is, it is called solvation. Now this magnesium hydroxide precipitation we discussed here. Next we will discuss. Suppose there is a iron in salt. So what is the solubility product constant? It follows in from precipitation tank towards clarifier. Suppose iron is present in salt, then it forms magnesium hydroxide. Fe plus NaOH, 3 NaOH equal to Fe OH thrice. It is the precipitation of iron. What is the Ksp value? Ksp value of the iron is equal to 1.1 into 10 to power minus 36. Then you see here FeOH3. It is Ksp is equal to say if it is S it is equal to 3S. It will give 3S Q. Then it is 27S4. 27 it will give S4. If precipitation follows the law of solvent product from PPT tank towards clarifier, and the total this law of solvent product completes in clarifier. So we will discuss now. We have discussed the ferric hydroxide, that is Ksp value of ferric hydroxide is 1.1 into 10 to power minus 36. Again, we will discuss the FeOH3 equal to Fe into 3OH thrice. If it is S, it is 3S cube. Total it will give 27 S4. Then this 27 S4 is equal to 1.1 into 10 to power minus 36. S is equal to 1.1 into 10 to power minus 36 by 27, and it is 1.4. It will give the 0.4492 into 10 to power minus 8. It is the solubility of the ferric hydroxide is 0.4492 10 to power minus 8. Then solubility of the ferric hydroxide equal to 44492 into 10 to power minus 9. It is 9. Into molecular weight of the FeOH3 is 107. It will give 4.807 into 10 to power minus 8, which is greater than this value. This value is 4.807 into 10 to power minus 8 is greater than this value, 1.1 into 10 to power minus 36. That's why there is a precipitation. Means it will precipitate. The magnesium hydroxide will precipitate in a PPT tank and completes in clarifier. Okay, like calcium carbonate, the Ksp value of calcium carbonate is 1.2 into 10 to power minus 8. Barium sulfate equal to 1 into 10 to power minus 11. Like this calcium carbonate and barium sulfate, their following the law of solubility product from PPD tank to clarifier up to clarifier. Now we will discuss in clarifier. In clarifier, we are using barium carbonate. Barium carbonate we are using to remove sulfate. To remove sulfate. So it is Na2SO4. SO4 into barium carbonate plus sodium sulfate plus barium carbonate. It gives barium sulfate and sodium carbonate and Na2CO3. Again this comes, it gets Na2CO3 plus Cl2. It gives calcium carbonate precipitation and 2 NaCl. Which here it is equal to double decomposition reaction. Double decomposition reaction in clarifier. You see this is barium carbonate. This barium carbonate, it is barium carbonate. It is a molecular weight is 233 and sodium sulfate. So sodium sulfate. So here you see whenever this barium sulfate and sodium it is one. It is 197. So it removes barium carbonate, removes sulfate. So sulfate equal to barium carbonate. It is 96. It is 197. So 197 divided 96. It gives 2.1 ton of sulfate will require 2.052. Then its purity is 97, 98, and the reaction efficiency is 0.85. So it will give 0.98 divided 0.85. Nearly it will give 2.46. 1 ton of sulfate will be removed by 2.463 metric ton of barium carbonate. Now you see it is a double decomposition reaction in clarifier. When you are charging barium carbonate to remove sulfate of the from the brine, then there is a double decomposition, because when you are charging barium carbonate, it gives sodium carbonate. Again sodium carbonate reacts with the calcium chloride and the reaction is completed. So here these two, this is molecular weight is 197 and it is 106. 1 is equal to 106 by 197 equal to 106 divided 197. So it is gives 538, 0.538. So you see here, from this double decomposition reaction, when you are charging barium carbonate, from side reaction you are getting sodium carbonate, Na2CO3. And suppose here we charged 2.463 metric ton of barium carbonate it will give it will give it will give uh, it will give 106 by 97 into 2.463. It will give 106 divided 197 into 2.463 means 1.325. You see, when you are charging to remove 1 ton of sulfate from the brine, when you are charging this barium carbonate from double decomposition reaction, you are getting from side reaction as a sodium carbonate, Na2CO3. You are getting this. Okay, beautiful. Now we discuss clarifier. In clarifier, there is what is the dimension of the suspended particles. There is 50 microns. The suspended solids. This is the dimension of the suspended particles in the clarifier, 50 micron. To remove this, it is called colloidal particles. Colloidal particles, and its charge is minus. It charge is minus. To remove these suspended particles, we are using magnafloc. What is magnafloc? Magnafloc is a polyelectrolyte in nitrogen free compound, and it is this is the positive charge. Magnafloc is a positive charge. It attracts to these particles. This is 50 micron suspended particles. This is colloidal particles. It is negative. It is attracts this, and this process is called interparticle bridging theory. This is called interparticle bridging theory, because this charge, this magnafloc, it is a magnafloc. This extends to maximum to attract the colloidal particles, negative charges of the suspended particles. And this process is called the interparticle bridging theory. And this process, total process is called as the process of agglomeration. Agglomeration. This is called agglomeration, and this is collecting and making heavy to settle down. And this total, the overall process is called the law of electroosmosis. Osmosis. What is this? Electroosmosis. It is the flocculent magnafloc. When you are adding magnafloc, this mechanism is going on. It is called due to magnafloc. It is called flocculation. Second, this charge is collecting and making mass to settle. It is called coagulation. Third, after the total mass completed and it settles at the bottom of the clarifier, it is called sedimentation. And this all the mechanisms are running in our clarifier, and this here this is maximum N2, the turbidity of the brine in outlet of the clarifier is maximum 5 to 8 NTU in worst case, but normally it is 5 NTU, 5 NTU, and it is then going to our anthracite filter. From anthracite filter, it is all the coarse particles of the outlet of the clarifier, it is arrested by the what is it, the anthracite filter, the coal powdered coal particles, and the N2 of the anthracite filter is nearly will get that is sorry the clarifier the clarifier is maximum this outlet is going to anthracite. In anthracite outlet we are getting because in clarifier it is 50 micron, the suspended particles it is going to anthracite. Anthracite in outlet we are getting 8 to 10 micron, 10 to micron particle size, the dimension of the suspended particles. Then it is going to Dr.M.Filter. Dr.M.Filter where the dimension of the particles sudden comes to down due to alpha cellulose. Alpha cellulose properties it is having agarose and dextran. It is the alpha cellulose have the dextran and agarose properties, and it comes down the micron of the dimension of the particles suddenly come down to nearly from alpha cellulose it makes 10 to power 3 to 10 to power from micro to micron. The particles which are after anthracite it is 80 micron. When it goes through alpha cellulose, it converts to from micro to micron. Sorry, from micron to nano. It is nano because in Dr.M.Filter from micron to nano, 10 to power minus 9. The properties of the alpha cellulose is to convert the dimension of the brine from micron to nano. So it is minus 10 to power 3 to 10 to power 9, and it's nearly N2 is 0.01 like this. Okay. So overall we will discuss the salt is being fed here, and it is making 310 GPL NaCl, and here it is come to PPD tank. Here your chemical reagents are added to remove magnesium, calcium sulfate. Then it is coming to clarifier. From clarifier it is total reaction. It is completes. Then it is up to that 50 micron dimension of the particles. Certain particles are removed by magnaflow, and all double decompository reactions are completed here. Then here it is coming to anthracite. Anthracite in outlet it is 10 to 80 micron of the dimension of the particles. The coarse particles of the suspended particles of the incoming from clarifier it is here it is arrested, and it is coming to Dr.M.Filter. Here we are using alpha cellulose. Through alpha cellulose properties of dextran and agarose. It total minimizes the minimizes the 10 micron dimension of the suspended particles to micro to nano. Here 10 to power minus 3 is converted to 10 to power minus 60 from micron particles to nanoparticles, nano dimension, and dimension. It is called at last we are getting this is polished brine. And next we will discuss the ultra pure and acidification alkalization. Thanks.